Good afternoon. So in chapter 5, we learned how to graph various functions. We learned how to graph something like f of x equals x. So we have a linear function. We learned how to graph f of x equals x squared. So we had parabolas. We even learned how to take something that we knew, like f of x equals x squared, and then transform its graph. So we learned you could do graph something like this, so the quantity x minus 2 squared minus 1. And we knew that that graph would be moved over to the left twice and down 1. That'd still be a parabola. So, how might we graph something like f of x equals 1 over x? What kind of function is f of x equals 1 over x? Is it linear? No. Is it quadratic? No, there's no x squared. And is it a transformation of a quadratic function? No, there's no x squared. So, we actually think of this kind of function as a rational function. And a rational function is a function that can be written as f of x is equal to some function g of x over some other function h of x. So, in this case, g of x equals 1 and h of x equals x. Alright, so I'll get this back. How do we want to graph this function? Well, when we have an unfamiliar function, we often like to make tables. So let's start by making a table and plotting some points. So we have x, and we have f of x. Alright, so we have x equals 1. 1 over 1, that's 1. So we come over here. And we have 1, and we have 1. So we have this spot right here. And we have, let's say, x equals 2. F of x will be 1/2. So here's x equals 2, f of x is about 1/2. What about x equals 3? Get 1/3. Or our x equals 5, 1/5. Okay, now how about something bigger? How about x equals 100? 100. 1 over 100. So, that is really close. It's down there somewhere. Okay. Now what about, we can see what happens after x is 1. We see it goes, so we can probably draw this in. But what about before x is 1? So what about x is equal to 1/2? We get 1 over 1/2, which is 2. So 1/2. I guess I better start drawing in some dashes on the y-axis. What about 1/3? We get 3. So 1/3, we're up there. What about 1 over something big, like 100? We get 100. That's interesting. Ooh, so we're really, really close. So now we have the second half of this. Now, just for the sake of being expedient, why don't we put a negative sign in front of all of those? And we'll get something like this. Wow, that's a very interesting graph. When we look at that graph, we see something kind of funny. What happens when x equals 0? We look at our graph. second. Okay, y-axis, x-axis. X equals 0. Huh. X is never 0. So, that tells us that we have a line here. X equals 0. That never is touched. We can also look at this graph. We can look at behavior of y. What happens is to y? What values can y be? Is y ever 0? No, y is never 0. So, x can't be 0, y can't be 0. And if we look at our equation, look at this for a second. Try to plug in 0 for x. Huh, what do we know about 1 over 0? Well, we remember that 1 over 0 is undefined. So, x can never be 0, because if x was 0, the equation would be undefined. And because x can never be 0, this actually means that y can't be 0 either. Alright, so what do we have here then? We do have these funny lines. We have two lines that are never ever touched by our graph. Does anyone remember what that's called? Well, if you don't, it's called an asymptote. A really hard word to spell. Silent P. So, an asymptote, for anyone who doesn't really remember, is a straight line that our graph gets closer and closer to but never actually touches. So, we can see in our example that we have two different kinds of asymptotes. We have one that goes vertically, and one that goes horizontally. So we can actually classify asymptotes into three different sorts. The first sort is vertical. It actually doesn't matter which order you name them in. A vertical asymptote. So we go back to our example over there. The vertical asymptote is the one that goes along the y-axis. So whenever x is equal to a constant, k, then there'll be a vertical, that would be the vertical asymptote equation. So in this case, k is equal to 0. All right. Second sort of asymptotes. You guessed it. They are horizontal asymptotes. In a horizontal asymptote, we can go back to our example where we have this and this, and this is the one that goes horizontally. So in this case, the equation for the asymptote would not be x equal to some constant, it was y equal to some constant. In this case, our constant is 0. Last but not least, we have a third type of asymptote. Now, I bet some of you have already guessed this. What happens when it's not vertical and it's not horizontal? It's a slant asymptote, or oblique, if you want to sound fancy. So, some line, not vertical, not horizontal, that our graph gets really, really close to, but never actually touches. So in this case, something let's call, this could be any sort of non-vertical, non-horizontal equation. So in this case, it looks something to be like y equals x, but it could be lots of different things. So in closing, there are 3 different kinds of asymptotes, and they occur when we have rational functions. Next class, we're going to learn how to find these asymptotes.